Right, now let me just walk you through how I synchronize the position from one avatar to other avatar. Like when I'm moving, other client will see my movement, will have to change my correspond avatar in their client into the correct position. Alright, let me start from the program inside Unity. So this is where the code start, where the transmission of the data start. It will start by the client, the user, move the avatar by using controller. I'm also assuming that you guys know how to write the controller, how to control your character inside Unity. If you don't know all of that, then you're gonna have to check out Unity's tutorial and other tutorial on YouTube on how to do those stuff. Alright, now when you move the character, like I said before, every time this client, the Unity client, will send the transform of your avatar to the server 10 times per second. And I'm going to just show you the code that it does that. It's called, this is the code, it's the network transform sender. So this one, it doesn't really do much. In here I'm just having some variable. This is a sending period, so it's not 0.1. That means 0.1 of a 0.1 second. That means 10 times per second. I can change this to 1 second. That to 1, that means it sends only 1 time per second. So you can change how many times you can just send the transform data, how frequent you send the data here. And yeah, we have last time sending. This is just a counter, like it count. It starts from 0 and then it count the times elapsed every frame, and when it reach 0.1, it will send the transform data, and then it will start doing that again. And the other one is called network transform last state. Last state here is simply it's just the transform, the current transform of your avatar in here, but it is stored in network transform class, which is a custom class here. You don't have to worry about that. This class is not really that complicated. It's just a helper to extract the transform from Unity into some format that can be sent to the server, because SmartFox doesn't really understand the transform class that is that built in with Unity. So you have to have some kind of method to extract the data from the transform, the Unity's class transform, and then put it into the server. That's about it. So this transform here, this is the class, isn't a transform object, which is the Unity object. So it's stored this dot transform, which is my current transform in my client. And yeah, now the method that send the transform is send transform here. It's run in a fixed update. So every fixed time it will be run by the client. And here, this is just the code to count the elapsed time, and then when it reach the threshold, which is 0.1 second, it will run this code. We send the transform. Alright, let's look into a little more detail. In here, last state, like I said, it's a network transform type, and it get the value from network transform dot from transform, and then it pass into this transform. This is the transform that is in the Unity object, the Unity class, and it just called this method so that it will convert the information, the transform information, which is the position and the rotation of your avatar, into network transform class. So it is last state here, the object of a network transform class. So that's all it does. and then it will call network manager dot send transform. So this class, this method, it will simply send. It will take the network transform object and then send that to the server. Now this is just a debug code, nothing more. So that's it. That's all network transform sender does. Nothing much. It just counts the time, and when it reaches 0.1 second, it will call network transform, network manager, and then call send transform and give the value last state here. Alright, let's look into the network manager class. So what it does after that in the send transform, here you go. This is the send transform class, method. So it takes network transform, yeah, and let me show you the goal, how the code that send the data to the server, which is this one. It's called it's a SmartFox.send request, and that request is of type extension request. Now what we want to do is just we want to populate the object of extension request, called request here, with the appropriate data, and then call SmartFox.send and put that request in, and that's it. And then this request will go into the server, will go into SmartFox. Yep. Now we simply create a new object, and we initialize it, create it. Now this is a parameter. There are 4 parameters. First, it needs a keyword. Like I showed you before in the server, it binds the keyword to the appropriate handler. So the first argument here is the keyword. You have to match those. You can just use whatever you want, any string you want, just as long as it match and it makes sense to you. Now just use send transform here, and the data, this is the transform data. So I will talk about that in a moment. And it needs a room and a boolean. So the boolean here is just, if it is true, then it will send in the form of UDP. If it is false, it will send as TCP. I'm not sure if you're familiar with UDP or TCP. I can just explain it a little bit. UDP is just it means unreliable data transfer. Unreliable data transfer protocol. It means what it does is just it transmits the data and then it's done. It doesn't wait for any acknowledgement from the server. So it doesn't know if the package will reach the server or not. So it simply just transmit the data. TCP, on the other hand, it's a reliable method, which when it sends the data, it will wait until it get the acknowledgement. The server tells it that it already received the data. Otherwise, it will wait for timeout. When it's timeout, it will resend the data to make sure that the server or the recipient get what it's supposed to get. So that's the difference between TCP and UDP. We use UDP here because the transform data is sent 10 times per second, and we simply like broadcasting like a radio. So we don't want to use TCP because it takes too much time. Sometimes when a package is lost, it will have to wait for acknowledgement, etc. So even if when we use UDP, we transmit 10 times per second, even if like one package lost per 10 package, then it's not really a big deal. That's why UDP, it kind of fit more in this way. So we're using UDP here, and the room here we don't have to really worry about it. The room is just a given. When you join the server, and then log in, then you start again, you join a specific room. SmartFox know all of that, so all you have to do is just create a room, call SmartFox.get last join room, and then just stick that in here. You can just copy the code. You don't have to understand anything. All you need is just up here you have some API that SmartFox provide to be used with Unity, and you just use all of that, and then you can just call SmartFox last join room, and then you get the room. That's it. Now let's talk about the data. This is the data that we get. We got from the network transform sender. We got as network transform in the form of the class is called network transform. But the data that it want to that it needs here is not a network transform. It's an ISFS object. That's the data it needs to be put into the request. So the reason why we need the network transform is just like I said, network transform is a helper class. It's got in there, it's got a method that that can construct the ISFS object that we need here using the information, the transform information. And let me just show you the network transform. Oh wait, let me just show you the method. It's called toSFS object. So the goal is we want an object called data of type ISFS object, and we want to put the information, the transform information, into that, and then stick it into the request. Okay, now we do that. We can inject the information, which is the position and the rotation of your avatar, into data here using this method called toSFS object in the network transform. All right, now how do this one inject into the data? Let me just show you the network transform. All right, yeah, and the class called toSFS object. Here you go. So it takes an ISFS object called data, and then what it does is just it creates a new ISFS object and data, and then it extract the position X, Y, and Z, and then put that inside the ISFS object data. Not data, the new ISFS object. So it just extract all the information, the position and the rotation, the angle rotation, and in here I also put a timestamp to know when this what is the time that the client sent this information to the server. So we have all this information, and then we wrap it up inside an ISFS object, and then I just put this TR, the whole ISFS object that I just inject all the information into, and then I put the whole thing inside data, which is the ISFS object that was sent from that in network manager need. So you got this, and then you inject you got the transform and everything, wrap it inside an ISFS object, and then put that inside another ISFS object. There you go. So that's how it works. You don't have to do the same way. There are many different ways to do this. This is just one implementation, and I'm just gonna show you. This is one way to do it, but you don't have to do the same way. It can be, sometimes it can be very complicated. Sometimes it's just unnecessary, but whatever. All right. Right, and this code is just I'm injecting the animation data inside that ISFS object as well. Yeah, so because I'm synchronizing both position and animation at the same time, but I don't want to go into too detail into that. Just trying to give you the concept of how the coding is written, and how it will be connected to the server, and just to give you an idea about how SmartFox and Unity is work together. All right, now yeah, you got the data inside an ISFS object, and I put animation inside that as well, and then I wrap it up inside a request, and then just call SmartFox.send request. and the package is gone to the server. Right, now let's go look at the server. Okay,